This video we shall discuss of further pure mathematics 2, paper 2, October, November 2024, paper 21. Let's take a look at the first question. Find the set of values of k for which the systems of equations given here has a unique solutions and interpret this situation geometrically. So what we need to do is to show that the determinant, we need to let the determinant not equal to 0 in order to have a unique solutions. 5 to 4 here, 6 to 8 here, not equal to 0 in order to have a unique solution. So this, after that we find the determinant. This will be 16 minus 8 minus a 5 of 8k plus 6, then plus a 6 of a 4k plus 6 not equal to 0. Expand and simplify. 24k plus 36 not equal to 0. Then we have a 14 minus a 16k not equal to 0. Therefore, your k cannot equals to the 7 over 8. Okay, so this is the set of k for the system of equations in order to have a unique solution. Then after that, for this case, since the for these unique solutions, what is the meaning of it in terms of geometrically? So you just say that these 3 points, these 3 planes intersect at a unique point. Okay, done. That will be the answer for the question number 1. Okay, so now we're moving on. We have question number 2. And y equal to arc cos of t, where the t is between 0 to 1. Show that dy dx equals to the t square over the square root of 1 minus t squared. So for these questions, it's quite straightforward. We just need to differentiate x with respect to t. Then after that, we differentiate y with respect to t. Okay, we can just apply the formula directly. Then our dy dx will be the dy dt divided by dx dt. Then it will be negative 1 over square root of 1 minus t squared divided by negative 1 over t squared. Cancel the negative, simplify it, then you get the answer shown. Okay, so this is the answer for part A. Now we move on to the part B. Now they want you to do the second derivative and show that second derivative can be expressed in such form. And A and B are the constant to be determined. Okay, so what you need to do now is just from the first derivative, you differentiate it again. Okay, that means you just need to put d square y ds square. From here, you just d square y ds square equal to differentiate this dt and dt dx. Okay, we just need to split them by using chain rule. So this will be d square over the square root of 1 minus d square. So what you need to do now is using the quotient rule, keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, divided by the bottom square. Okay, so just like that. And not to forget to write down the dt dx. So the dt dx is actually a negative d square. Then what you need to do now is we simplify first. Okay, there's no hurry for us to simplify them direct get the answer. So it's better we simplify them carefully. You get this one as a plus of 2t cubed. Not no 2t cubed. The 2 has been cancelled. You have a t cubed and 1 minus t squared power negative half over the 1 minus t squared. Then the whole thing here need to multiply by negative t squared. So now we can try to factorize a common factor out. We will factorize the t out. The t squared over here, I write it as a negative t squared. I factorize the t out. I factorize the 1 minus t squared power negative half out. Then inside here, I left with only okay, this one I factorize it. This is a power half. Okay. So if you factorize the common factor, this, then for the first term, you will left with only 2 of 1 minus t squared. Then this one, it will be plus t squared divided by 1 minus t squared power 1. Then we simplify it. You get negative t cubed. These two can combine together. Okay, we can combine these two together. So it will be 1 minus t squared power negative 3 over 2. Then inside here, we just expand and simplify. Expand and simplify, you will get this answer as 2 minus a t squared. Okay. So if you compare to the form, this is exactly the form that we want. Okay, so therefore, my A is a 3, my B is a negative 3 over 2. Okay, so this will be the answer for question number 2B. So now we move on. Question number 3. Y equal to e power x. For the x is between ln 4 over 3 to ln 12 over 5. The area of the surface generated when the curve is rotated through 2 pi radians about the x-axis is denoted by A. So we are using the formulas of the surface area. Use the substitution u equal to e power x to show that the A equals to 2 pi integrated from 4 over 3 to 12 over 5 square root of 1 plus u squared du. So for these questions, first of all, we need to find the dy dx. Your y is e power x, your dy dx is e power x. Okay. Your area is equal to the 2 pi integrate from ln 4 over 3 to ln 12 over 5. Okay, 2 pi y square root of 1 plus the dy dx square. This is the formula. Okay. So now we will be having this as a ln 4 over 3 to ln 12 over 5. The y is e power x, and the dy dx, this one will be e power 2x. Okay, so at first we write like this. Then we just now change the u become e power x. Yes, u become e power x. So my du dx is equal to e power x. My du is equal to ex dx. Then when the x is equals to the ln 4 over 3, that will give you u equal to 4 over 3. When the x is equal to the ln 12 over 5, that will give you u is equal to 12 over 5. So therefore, your A, it will be integrate 2 pi, become 4 over 3 to 12 over 5. This is a EX, this is the DX, this one will become a DU. The whole thing over here, it will become square root of 1 plus U square, shown. Okay, so this is the answer for the part A. Okay. So now, based on the answer in part A, we want to use another substitutions. Your U this time is a sine V. Okay. So based on this, you will use U equal to sine V, and then you want to solve it. So we will need to differentiate du dv, not du dx. Du dv is equal to the cos V. Okay. And the du will be equal to the cos V dv. When your u is equal to 4/3. So what happened to the v? We need to find the v. So 4/3 is equal to sine v. The v is equal to the arcsine of 4/3. Using the natural log form of the inverse hyperbolic, you will get ln 4/3 plus square root of 16/9 plus 1. Simplify it, you will get ln 3. Okay, then we need to do another one. When the u is equals to 12/5. So my v is equal to the arcsine of 12/5. That will be equal to the ln of 12/5 plus square root of the 144/25 plus 1. Just use your calculator to simplify it. You get ln 5. Okay, you get ln 5. So, therefore, your A right now can be written as integrate. Right? From here, 4/3, it will become ln 3. Then 12/5 will become ln 5. This one will be square root of 1 plus sine square V cos V dV. Okay, so now the question has become this expression. And you need to use the hyperbolic identity. You should know that this one will be same as a cos square V. And you square root it, cos square and square root it, you will get cos V. Cos V times cos V, you have a cos square V. You're supposed to get something like that. And we continue further to integrate hyperbolic function with square. We just apply the concept, the strategy, same like the trigo. We use the hyperbolic identity, making this become cos 2v plus 1/2 dv. Okay, so we are using a hyperbolic identity also. Direct apply it. Okay, so now we will be having the 2 can cancel. So this one will be pi. We integrate this, cos 2v will be the half sine 2v. Integrate 1, you get a v. Then you have a ln 3 to ln 5. So if you use your calculator, we put in the value first. This one will be 2 ln 5 plus the ln 5 minus a half of sine 2 ln 3. Minus ln 3. Okay. So we need to use calculator. Okay. You can use calculator to press the sine 2 ln 3. Okay. So over here, just a remark here. Sine 2 ln 5 by using calculator, it will give you 312/35. Then sine of 2 ln 3 by using calculator, you can get 40 over 9. Okay, so this one, it will be pi. It will be 312 over 50, because this one there's a 2 here. Then this one will be ln 5 divided by 3. These two I direct combine together. Ln 5 minus ln 3, I get ln 5 over 3. Then this one, it will be minus the 40 over the 18. Okay, so now press the calculator, simplify it, you will get this answer as the 904. Combine these two fractions become 1. Combine these two fractions become 1 just by pressing calculator. Then you get 904 over 225 plus the ln 5 over 3. Done. That's it. Shown. Yeah. So we need to show the answer here. Okay. So this will be the answer for the question number 3B. Okay. So now let's move on to question number 4. Given as following here. Show that the 111 is an eigenvector of the matrix A and state the corresponding eigenvalue. So for this case, since they already give you the eigenvector, how to show that is eigenvector. So how to show it, we just need to take the vector, multiply by the matrix, and it should be the multiple of the original vector. So if we take this, multiply 1, 1, 1. So just calculate it. You will get this as a -2, -2, and -2. So we factorize the -2 out. You get 1, 1, 1. The value here and the value here same. So the multiple of -2, this will be your eigenvalue. So from here, it's just like this. You just say, therefore, 1, 1, 1 is an eigenvector of A with eigenvalue lambda equal to -2. Okay, so this will be the answer for part A. Done. Then part B, show that the characteristic equations of A is lambda cubed minus 19 lambda minus 30 equal to 0, and hence find the eigenvalues of A. So in order to show the characteristic equation, we need to find the use a formula for finding the eigenvalue. So we have a -11 minus lambda. Okay. Basically, just take this value here, the diagonal here, everyone minus a lambda, and then after that you find the determinant. So -2 minus lambda. This is a 1. This is a 8. -2 minus lambda. 13 minus lambda. 0, 0 here. -16 and 1. Okay. Equal to 0. Then just finding the determinant. Over here, I factorize the negative out. It will become lambda plus 2, lambda minus 13, minus a 1 multiply 0, plus the 8, multiply over 0, plus the, this one is a minus, equal to 0. Okay. So we can see that this and this are common factor. So I don't plan to expand them first. I plan to factorize lambda plus 2 out. Okay. Then I will going to factorize the negative out as well. So inside here, I will get lambda plus 11, lambda minus 13, then plus with the 18, 8 multiplied 16. 8 multiplied 16 is 128. Okay, equal to 0. So the negative actually can bring to the other side. You can make it like this. You can ignore the negative. Then here you get lambda square minus 2 lambda minus the 1, 3, 143. So expand and simplify, you get the lambda square minus the 2 lambda minus the 15. Okay, and if you expand further, you can get lambda cube minus the 2 lambda square minus the 15 lambda plus 2 lambda square minus the 4 lambda minus the 30 equal to 0. Therefore, you successfully, this one can cancel. 19 lambda minus the 30 equal to 0. Shown. Okay, this is how you show the characteristic equation of A is lambda cube minus 19 lambda minus 30. But we haven't finished it because we need to find the eigenvalue. And in order to find the eigenvalue, we just need to use this result. Okay, we factorize the quadratic portion. It will be lambda minus 5 and lambda plus 3 equal to 0. Therefore, your eigenvalues, it will be negative 2, negative 3, and then 5. So this will be the eigenvalues. Okay, so done. This is the answer for the number 4B. Haven't finished yet. We still have 4C. Use the characteristic equation of A to find the A inverse. So this is the characteristic equations of A. Okay. So in order to find inverse, we will need to apply something called the CAIE-Hamilton theorem. Just mention CAIE-Hamilton theorem. So we will be having A cube minus the 19A minus the 30I is equal to 0. So you will get 30I is equal to the A cube minus the 19A. Okay. To get inverse, so you get 30A inverse is equal to the A square minus the 19I. Okay. So now, in order to find this A inverse, the 30 must go here to divide. But I try not to deal with the fraction so early. And the moment I go and find A square. Okay, A square will be the matrix negative 11, negative 16, and then 1, negative 2, 1. And another one is 8, 0, 13. So similarly, you multiply the same matrix. 1, negative 2, 1, 8, 0, 13. So just expand that, simplify it. You will get this one as a negative 7, 0, negative 12, negative 5, 4, negative 5, 16, 0, and 41. Then we'll get A square. Okay. So therefore, your A inverse is equal to 1 over 30 of the A square. (16, 0, 41) minus 19, 19, 19, 0, 0, 0, 0, 0, 0. Okay. So now just use your calculator, simplify them, and you get the answer as negative 36, 0, negative 32, negative 5, negative 15, negative 5, 11, 16, 0, 22. That will be your inverse of the matrix A. Okay, so let's move on. Now we go on to the question number 5. Given that when t equal to 0, x equal to 12, and dx dt equal to negative 6. So what we need to do is at first we write the auxiliary equations, AE, make it become 6m squared minus a 5m plus a 1 equal to 0. Factorize it. Then you will get the m is equals to 1 over 3 and half. So from here, you can get your complementary function, CF, the XC as the AE power t over 3 plus the BE power t over 2. Okay, so this will be your first part of the solution. Now we go for the particular integrals, BI. There will be XP. We having a quadratic equations over here. So the general form for the quadratic equation will be the AT squared plus BT plus C. So we differentiate it for the first time. And we differentiate for the second time. You get a 2A. So replace them inside the differential equations. 6 second prime. And then 5x prime. Then plus xb. That will be equal to the t squared plus t plus 1. So just substitute them inside. You get a 12a minus a 5 multiplied 2at plus b plus the at squared plus bt plus c. Is equal to the t squared plus t plus 1. So we rearrange everything by grouping the same term together, the like terms together. It will be b minus 10a, t over here. And this one, it will be 12a minus the 5b plus c is equal to t squared plus t plus 1. So by comparison, we have a is equal to 1, b minus 10a is equals to 1. Okay, so that means the b will be equals to 11. And then the last one, it will be 12a minus a 5b plus a c is equal to 1. That will give you the c is equals to the 1 minus 12 and plus 55. And you solve it, you will get it as a 44. Okay, so we found a particular integrals, xp. So your x is equal to the xc plus xp. That will be equal to the ae power t over 3 plus the be power t over 2 plus the at squared plus bt plus c. That will be your general solution. We are looking for particular solutions. So for particular solutions, we need to differentiate it for one more time. 1 over 3 ae power t over 3 plus the half b e power t over 3 over 2 plus a 2t plus 11. And given when the t is equal to 0, x is equals to 12. Okay, so this is what they give you from the informations over here. d equal to 0, x equal to 12. So you just need to replace a 12 here from here, put 12 inside, then the d becomes 0. You will have a plus b plus the 44. So you will get a plus b is equals to the negative 32. Okay, I think we need to solve a simultaneous equations. We can just make the b as a negative 32 minus a. I call this one equation 1. Then when the d equal to 0, your x prime is given as negative 6. So we will replace them inside these equations. Negative 6 is equal to the 1 over 3a plus the half b is equals to plus 11. Then from here we simplify them. We will get this one as a 1 over 3a plus half b is equals to the negative 17. I call this one second equations. 1 into 2, you will get 1 over 3a plus the half of the b, right? This is a is equal to negative 17. And if you just expand and simplify, you will get this one as a negative 1 over 6a is equals to the negative 1. Okay, so therefore the a is equals to 6. And from the equation 1, you have the b is equals to the negative 38. Okay, so we found the a and b, and therefore our particular solution x will be equals to the a e power t over 3 plus the b e power t over 2, then plus the t square plus 11t plus the 44. Done. This will be the particular solution for the second order differential equations over here. So number 5 is done. Now we move on to question number 6. The curve with the equations y equal to the half power x, where the x is from 0 to 1, together with a set of n rectangles with each of the width is 1 over n. By considering the sum of the areas of rectangle, show that the integrations, the area here is greater than the ln, where the ln is given as such. So we need to show that the ln look like this, the lower bound value. So what you need to do is, for me, usually I will just let this equation as a fx. Okay. Then after that, because we want it to be the area of the integration here is larger than the area of rectangle. So we are taking the lower rectangle here. So if we are taking the lower rectangle, that means over here, the integrations from 0 to 1, the half power x dx, it will be greater than the f1 over n multiply 1 over n plus f2 over n multiplied by 1 over n plus until the f of the last one here is n over n multiplied by 1 over n. And this will be the same as a 1 over n. You can write them in a sigma notation. Your r from 1, fr over n, something like that. Okay, then we change the expressions of the function, become half power r over n. Okay, so half power r over n, actually this is a geometric progression, is a GP, where the first term a is equals to the half power of 1 over n, and your common ratio is also half power 1 over n. Okay, So you're having the same, the first term and the common ratio are the same. So the formula over here, it will be 1 over n. A, then 1 minus the r, and you power n of it. Okay, so it will be n over n. Then inside here, the denominator will be half power 1 over n. Okay, power 1 over n, sorry. Okay, so this will be the expressions. And we can simplify. Okay, you can see that this part over here, it will be a half if you expand and simplify it. Okay, so you will get this one as a this. Because the answer over here, you can see that this one is 2, not half. Okay, the base over here is 2, not half. So I will make this become 2 power negative 1. Okay, so over here I will write it as a 2 power negative 1 over n divided by n, then 1 minus a 2 power negative half. Okay, like this. Then after that, in order to get a 1, I need to multiply 2 power positive half, positive 2 power positive 1 over n, multiply 2 power positive 1 over n. Then you get this one as a 1. Then you get this as the 2. There's a half here. There's a half here. Okay, so there's a half here. So 2n. Then you will get 2 power 1 over n minus a 1 shown. This is how you get the lower bound value. Okay, so for part A, consider done. Okay. Then move on for the part B. They want you to use a similar method to find the upper bound. Okay, so for the lower bound, it will be upper bound. Sorry, it will be the same method, but this time your triangle, you need to choose the higher triangle. So to choose the higher triangle, you will need to choose, start from the rectangle here. This is the rectangle. This is the rectangle. So you start from f0, 1 over n. Okay, f0 multiplied by 1 over n. So this one will be f0 multiplied by 1 over n plus f or 1 over n multiplied by 1 over n plus until f n minus 1 over n multiplied by 1 over n. And we can do a bit fast right now. It will be f r over n. This r start from 0 until n minus 1. Okay. However, we still have the same n terms over here. So this is still GP. It's still a GP of a half power of r over n. Okay, it's still a GP where the a is equal to 1. This time the a is equal to 1 because your r starts from 0. And your common ratio is still half to the power of 1 over n. Okay, so if we use the formula, it will be 1 over n, 1 multiplied by 1 minus this n over n divided by 1 minus this. So this time you will get half divided by n. Then this is 1 minus a 2 power negative 1 over n. Then I multiply 2 power 1 over n, and I multiply 2 power 1 over n inside. So I will get this one as a 2 power 1 over n divided by 2n. Then this is a 2 power 1 over n minus 1. That will be your upper bound. Okay, this will be your un. Okay, done. Now they're asking you to find the least value of un minus ln less than or equal to 1 over 3. So the un minus ln, un is this. This is a un. And the ln is just now from the previous one. Ln is 1. Less than equals to the, I make the 10 to the power of negative 3 as 1 over 1000. So when you combine them together, you get this. Same denominator, just combine the numerator directly. So you can see that this one can cancel. That means your n is greater than 500. So the minimum value, it will be 500. Just like that, done. That will be the answer for the questions number 6C. Oh, we still have a D, okay? We still have part D over here. So the part D is they asking you, given that the value over here is equal to the 1 over 2 ln 2, find the value n found in the part C to find the upper and the lower bounds for ln 2. Okay, part C. Use the value of n found in the part C. Our n found in the part C is actually 500. Okay, 500. So, okay, we make this is between the un and the ln. Okay, our ln is 1 over 2n of 2 power 1 over n minus 1. This is a 1 over 2 ln 2. Then this is a 2 power 1 over n over the 2n 2 power 1 over n minus 1. Okay, so we can actually cancel the 2 here, and we make it ln 2 is actually between n 2 power 1 over n minus 1 and n 2 power 1 over n minus 1 over the 2 power 1 over n. So n is equal to 500. So you just need to use your calculator. 500, 2 power 1 over 500 minus 1 divided by 2 power 1 over 500. This is a ln 2, and it's between of 500, 2 power 1 over 500 minus 1. So you just use your calculator, press it only. You can see that this upper bound, it will be 0.694. This lower bound will be 0.693. So done. That will be the answer for the question number 6D. Moving on, we have question number 7. Over here is that we need to change them to the standard form, which is the dy dx, 1 dy dx over here. Then it will be 1 over the square root of x squared plus 16. Y is equal to x. So I am actually dividing everyone by square root of x squared plus 16. Then from here to find the IF, just take a e to the power of this. To integrate them, just get it from formula booklet MM19. You can find that the answer will be arcsine of x over 4. Then because we know that the inverse hyperbolic function can be written as logarithm function, then it will be look like this: x squared over 16 plus 1. And from the property of the logarithm exponential function, e power ln of anything here, it will be the answer same. Okay, so we are having a relationship that e power ln of fx equal to fx. So our answer here will be x over 4 plus the square root of x squared plus 16 over 4. Okay, you can just change it to this form. Shown. Okay, so this will be the answer for the number 7A. Then now we move on to the 7B. Okay, now they want you to solve these differential equations. So to solve this differential equation, we will start from here, where we get the IF just now. When we get the IF, we are leaving that in the expression like this. So now I multiply everyone by the IF. I will get x over 4 plus the square root of x squared plus 16 over 4 multiply dy dx plus the x plus square root of x squared plus 16 over the 4 square root of x squared plus 16 multiplied by y equals to, not in our place, I will just write is equals to here, equals to the x squared over 4 plus the 1 over 4x square root of x squared plus 16. Okay, so once we multiply the IF, the left-hand side, the result will be only having the IF multiplied by the y. And the right-hand side, we need to integrate the whole thing. So just take the IF, let it multiply by the y, and the right-hand side, I will be just integrating the whole thing over here. So in order to make the integration process is easier, I will change this square root become power of half. Okay. So my left-hand side already fixed. I just focus on the right-hand side. It will be s cubed over 12. And this one, it will be a bit troublesome. Okay. So over here, you need to have integrating half. You need to have 2x. This is a x squared. This one is a 1 over 8, 2x. Okay, then this one is 16 half dx because I'm using the formula of f prime multiplied by fx power half. I'm using this formula to integrate. Okay, so if I'm using this formula to integrate, then my result will be x cubed over 12 plus the 1 over 8 x squared plus 16 power 3 over 2 divided by 3 over 2 plus c. Simplify everything, you get s cubed over 12 plus the 1 over 12 of s squared plus 1 plus 16 power of 3 over 2 plus c. Okay, so now we need to find the c. So given that when the x is equal to 3, the y is equal to 6. Okay, so from this relationship, change the x here become 3 over 4 plus the square root of 25 over 4 times 6 is equal to the 3 cubed plus 12 plus the 1 over 12 of 25 power 3 over 2. Simplify everything just by the help of the calculator. You can find that the c is negative 8 over 3. So therefore, I have my answer here as x plus the square root of x squared plus 16 over 4y is equals to the x cubed over 3, s cubed over 12. Then plus the 1 over 12 of x squared plus 16 power 3 over 2 minus 8 over 3. Okay. So actually you can just bring this go to the other side. Then you will get this one as an x cubed plus the x squared plus 16 power 3 over 2. Then this one, it will be minus a 24 over the 3 of x plus the square root of x squared plus 16. Okay, You can leave the answer like that as well if you want to. Okay, so not 34, sorry, I make a mistake. This one is 32. Okay. Yeah, that's it. So this will be the answer for the question number 7B. Okay, and moving on, we have question number 8. The binomial expansion where the z equal to cos theta plus I sine theta show that by using the De Moivre theorem show that this relationship is true where the A, B, C, D are the value to be determined. So what we can do is that we need to define that z is equal to cos theta plus I sine theta. That will give you 1 over z is equal to the cos theta minus I sine theta. Okay, so this will give you z plus 1 over z is equal to the 2 cos theta. Okay, that will give you z power n plus 1 over z power n is equal to the 2 cos n theta. We need to clarify the relationship here first before we start doing the binomial expansion. So now, z plus 1 over z power 7 is equals to the 2 cos theta power 7. Okay, so I will write this 2 cos theta power 7 to the to my right hand side, to my left hand side. Okay, so I make this one become 128 cos power 7 theta. Then my right hand side, I will write the expansions of the binomial expansion here. Z power 7 plus the 7z power 5 plus the 21 z power 3 plus the 35 z plus the 35 divided by z plus the 21 divided by z cubed. Plus the 7 over z power 5 plus the 1 over z power 7. So if you use a binomial expansion, you can just expand them directly. So what we are doing here is that we group the z power 7 and 1 over z power 7 together. We group the z power 5 and 1 over z power 5 together. We group the 21 z cubed plus 1 over z cubed together. And we group the z power 1, 35. It will be 35 of z plus 1 over z together, if we group them together. So by using this relationship, you get this one as the 2 cos 7 theta plus the 14 cos 5 theta plus the 42 cos 3 theta plus the 70 of cos theta. I just need to divide everyone by the 128 because I am looking for cos power 7. So divide by 128, you get 1 over 64. Divided by 128. So you get 1 over 64 cos 7 theta plus 7 over 64 cos 5 theta plus the 21 over 64 cos 3 theta and plus the 35 over the 64 cos theta. Okay, so done. We have found the answer, the A, the B, the C, and the D. So we have found the A, B, C, D. So this will be the answer for the question number 8A. So now we're moving on to the question number B. They are giving you the IN. So this one is a maybe reduction formula. So we need to integrate this. IN is equal to the 0 pi over 4 cos n theta d theta. So what you need to do is we will borrow cos n minus 1 theta, cos theta go out like this. Okay. Then this one, we will going to integrate. Okay. This one we're going to bring out. Cos n minus 1 theta, integrate cos theta, you get sine theta. Okay. Then you put 0 to pi over 4. Minus the integrate 0 to pi over 4. The one that bring out, you differentiate cos n minus 2 theta, then you get this as a negative sine square theta. I'm using integration by part. I just put in the value directly. So over here, I will get cos pi over 4. Cos pi over 4 is a 1 over sec 2. Okay, 1 over sec 2 minus a 0. Then this one, it will be plus n minus 1, integrate this. Cos power n minus 2 theta. This one sine square, we make it become 1 minus cos square. By expanding them, this one, it can make it become 1 over sec 2 power n. Then you will get something like this. Cos power n minus 2 theta minus a cos power n theta d theta. Okay. Then by expanding them, simplify it, you get 1 over sec 2n plus the n minus 1 of I n minus 2 minus the n minus 1 of I n. This is I n. So join together, you have n I n is equals to 1 over sec 2 power n plus the n minus 1 I n minus 2. According to the questions, we do not want to see square root. We want to see 2 power negative half. So this will be 2 power negative half n plus the n minus 1 I n minus 2 shown. Okay, so this is how we show it. Okay, this is how we show it. Okay, so this is the answer for the part B. Now we move on to part C. Using the result given in part A and part B, find the exact value of I9. So to find the exact value of I9, when the n equal to 9, from the formula here, it will be 9I9 is equals to 2 power of negative 9 over 2 plus the 8I7. Okay, so this is what we have. So this one I call equation 1. Then I7 is actually equals to integrate 0 to pi over 4 of cos power 7 theta d theta. But just now in part A, we already found the relationship of integrating the, just now we found the relationship of cos power 7 theta can be written as 1 over 64 cos 7 theta plus the 7 over 64 of cos 5 theta plus the 21 over 64 cos 3 theta and plus the 35 over 64 of cos theta d theta. Just directly apply the result in part A. And now if you integrate it, you will get, I just take the 1 over 64 out to make our integration easier. So this one you get 1 over 7 sine 7 theta plus the 7 over 5 sine 5 theta plus the 21 over 3. 21 over 3 is a 7. So this one is a 7 sine 3 theta plus the 35 sine theta from 0 to pi over 4. Okay. So now we need to put in the value. If we put in the value, it will be 1 over 7 sine 7 pi over 4 plus the 7 over 5 of sine 5 pi over 4 plus the 7 of sine 3 pi over 4 plus the 35 of sine pi over 4 minus a 0. Okay, so we have to be aware of the value. We can just get the help of the calculator sine 7 pi over 4. That one is 315 degree. So this one, it will be negative 2 over 2. Okay. Now I think maybe we negative 2 over 2. Maybe I put it like this first. Okay. Negative 1 over 2 first. This one is 7 over 5. This one is also negative 1 over 2. This one is 7 over 2. This one is 35 over 2. Then I am joining up all together by using calculator, joining them up together. So you will get the answer as 177 over 280 2. Okay, 280 2. So now I have found I7. Now I just need to put the I7 back here, simplify it, then I get the answer. So from the equation number 1, 9I9 is equals to 2 power negative 9 over 2 plus the 8 multiplied by 177 over 280 2. So I will make this become divide everyone by 9. Okay. So this one, it will be 2 to the power of negative 4 multiply 2 power divided by 9. This one will be 177 divided by 315 2. So if you continue to simplify it, you will get this one as 1 over the 144 2 plus the 177 315 2. And if you combining them together, you get 2867 over 5040 2. But if we want to rationalize the denominator, just multiply 2 and 2. Over here, you will get 2867 2 divided by 10,080. 10,080. So this will be the answer. This will be the answer. Okay. So, and this will be the last question for this paper. Okay. So I'll stop the video here. I'll see you next time, and bye-bye.